Hello, everyone. Welcome to a topic on methods of constructing index in numbers. The methods of constructing index numbers can be grouped in two categories. The first category is index that will be constructed using without any weight, that we call unweighted indices. All items are treated equally without assigning different levels of importance or the weights. So you can compute index without assigning different levels of importance or weights to their items. So assumptions here is that all items have the same the weight, so the same importance. So under unweighted indices, the method you can, if you want to compute unweighted indices, that will be using is a simple aggregative method, or you can use a simple average of relatives. So these are the two methods that you can use in computations of unweighted indices. While the second will be weighted indices. And these methods normally we apply when the items have different weights or have different importance in the measurements. So if you find your items have different weights or have different importance, then will be compute weighted indices. And the method you can apply here will be weighted aggregative method. And where under weighted aggregative methods, you have the three methods. That is, either you can apply as pairs methods, or you can use a partial methods, or you can use a Fisher ideal methods. But also you can compute weighted indices using a weighted average of relative methods. So we'll go decide discussing one by one and do some examples. So we start by unweighted indices. So the first method, as previous slides, you can use a simple aggregative method. And this is just taking a ratio of the prices of current and the prices of the base time. So you can compute using the prices of commodities or items, but also you can compute an weighted index using quantities, or you can use a value. So the formula here, like this first formula of deriving the index, this will be for the prices. So you take a prices of the current time, you divide by current of the base time. So because it's aggregative, it means will be a summing current prices of all items, and it will be the sum of all prices at base time for all items. Then you multiply by 100. So the P0 will refer as the base year price, and Pn will refer as current year prices. And this will be the price. In case you want to compute for the quantity, maybe the P will be replaced by Q and be Qn, and here will be a Q0. And if you want to find for the value, you'll be multiplying the price, current prices, and the current the quantity, the denominator will be the base price and multiplied by the base quantity. So the formula will change depending on either you use the prices or quantities, or you need for the value. Let's see an example of computation of the price index using a simple aggregative method. And you have different commodities, A up to E, and then each commodity will have the unit, kilogram up to the liter. And then you have the prices of these commodities, the base period, that's P naught. And also we have prices for each item at the current time, that's 2015. So if you want to compute the price index here, that will be unweighted. So the formula will be this form. We will be using this formula, and here we have different prices. So it means we will be summing the prices for the current time, that's the PN. That would be a total, and prices at the base time for all commodities or the items, and this will be total will be here. So the index will be simply by dividing this value here, 221.2, they will divide by 166.4. So that would be the answer. Then you multiply by 100. So this will be your index. And if you want to interpret this value, it means there is a net increase of about 33% in the price of commodities in 2015 as compared to 2010. So that's the simple the calculations of computing the index using a simple aggregative method. As I said, you can use the prices, or you can use quantities, or you can use a value. The second method will be a simple average of relatives. So this is a formula you can use in computation of indexes. And here will be the same. You can use arithmetic mean. If you're using arithmetic mean, you'll be take 1 over number of items that you will be you have. And here you take the issue of the average of relatives. It means you need to find the ratio of the quantity at the current time divided by quantity at the base time. So I'll be taking a ratio of the quantities, or you can also take the ratios for the prices, and then you multiply by 100. But if you want to use a GM, stand for geometric mean, it means you have to take the nth log of the 1 over summation of the log of the relative, this relative whether prices or it can be quantities, and you multiply by 100. So this is a formula for computation of the index number using a simple average of relatives. The key issue is the average of relatives. It means you need to have the relative of is a quantity at current time and the base time, or the prices, depending on the data you have. Let's see quickly an example here. Same examples, we have items of commodity A up to E, each one having a different unit, and then you have the prices for at the base time, and you have prices at the current time. That's P naught, P1, or you can use PN. And you need now to use to compute using index using simple average of relatives. So I'll be using now, here I'll be using the prices, because the data we have, We have for the prices. So it means will be so you'll be using this formula, and you'll be dividing the ratio of these prices at current time. Take divide by the base time, then you multiply by 100. So for instance, because we have constructed a table, what you do first will be taking the 170 divided by divided by 50, and then well, divided by 50 times 100. So I'll be taking this this is called a relative prices. So like 50 divided by, sorry, 70 divided by 50, and then you multiply by 100, you get 140. The same for the second item, 60 divided by 40, you get multiply by 100, then you get 150. So we do the same for all items. And then after, maybe you can sum over here. If you do sum over all of these values here, you will be getting 162. And then you divide it by 5, because here in this example, you have the 5 items. So this is how you get the index using this simple average of relatives. And after getting your index, now it's 122.4. So here you have 22.4. That will be net increase of the prices from 2010 to 2015. So now we'll be moving to weighted indices. And as I said, you have unweighted or weighted indices. And for weighted indices that you want to compute, you can use as a weighted aggregative method. Where here we have the 3 methods as I presented earlier. That's either a Spear's method, or you can use a Pasch method, or you can use the Fisher-Ideal methods. But also you can use weighted average of relatives, like we did for the unweighted indices. So Laspierre's method, also when you want to compute for index using Laspierre's method, you can base on the price, or you can base on the quantity. So if you base on the price index, it means your weight will be on the quantity. So your base year quantity will be your weight. And the prices will be now changing for current time and base time. But if you need to compute Laspierre's method, using Laspierre's method, but you want to compute quantity index, it means here the base price will be your weight. So it depends of the data that you have. So if you have given a data, like I have different items here, you have a price and quantity for the base year, the price and quantity for the current year. So it depends. If you want to compute the price index number using Laspierre's method, it means your base quantity will be your weights. And if you want to compute quantity, then the base places will be your weights. So that's something to understand. So it means you can, from this data, you can construct either you can construct for the price index, or you can construct for the quantity index. But it means you need to have the columns for the columns for the for this PN Q naught, P naught Q naught, QN P naught, because this the summation of this will be used in the formulas. So it's like for the price, where you need to have the PN Q naught, P naught, and the Q naught. It means you get from the, after multiply, you can get from the down here, the P naught, Q naught, and the P naught and Q naught. So this will be, so you can substitute in the formula. So like here you have 555.9, 360.16. So you can just plug in the formula, taking from the table here, and plug in the formula. It's 165.4. So this implies there is an increase of 65.4 price increase, this percent from 2 period of time, from 1995 up to 2005. Okay, now we can also use the partial method in computation of the index number. That's the weighted aggregative method. Also the same we can do for the price, or for the price index, the price index for the partial. For the partial, then the quantity will be, that's current quantity will be your weights, if you want to use a partial method. So here I'll be using a quantity at current time will be your weight. That is compared to spares where it's using at the base, which will be at the base time, but partial use at current time. So if you have for the price or for quantity, then the price will be your weights. The current price will be your weights. Example, we have the same example, but this time we need to compute the index for the using a partial method. It means the current quantity or the current price. This will be now the weights will be used in the formulas there as the weights. For instance, for the price, then here will be taking current quantities to be weights. So it means you need to just construct the table, and depending on what you want to compute, like if you need the PN, QN, P naught, Q naught, it means in your table you need to have PN, Q naught, P naught, QN. So that will depend. So that at least when you have these two columns, then you'll multiply, and you just get a total down here, and then you'll just divide the values and get your index number. And the last, for weighted aggregative method will be a Fisher, the ideal methods. And this also will be a product of Laplace pairs and a partial methods. These formulas you just multiply, and then you multiply by 100. So it's like you compute Laplace pairs, and then you compute the partial index, and then you multiply the two under square root. After you take the square root, then you multiply by 100. So it's the same flow. If you have this example here, you have price, base time, and current time. You have quantity at the base time and the current time. So it means you need to add these columns. Pn, Q naught, Q naught, P naught, Q naught, Pn, Qn, P naught, Qn. So that when you multiply from the data, so I'll be just taking here the total and plug in the formula and get the index. So that's how you can compute weighted aggregative methods, either using Laplace pairs or using a partial method or using the Fisher ideal index. And the last is weighted average of relatives. When you see the weighted relatives, it means you need to have a ratio of the prices, the current and base. Then you multiply this value here, and then down here will be summing over the value. Or if you're using a GM, then you can apply antlog of this value here and get the index. For example, we have now the three commodities, and each one you have the base price, and then you have a quantity at the base here, and you have a price current. And if you need now to apply this formula, so you need to have like a ratio of the Pn over P naught. This can be a P1 over P naught, then you multiply by 100, and then you need this value P naught Q naught, and then down you have summation of the P naught Q naught. So what you're supposed to do, just having first P naught Q naught, can call it V. So you can multiply this value like 3 times 20, you have 60. 1.5 times 1.6, you have 60. 1.0 times 10, you have 10. So this will be P naught Q naught as in the formula. So you can call it like this, call like a V. And then you can sum over, because denominator you need to sum all of this P naught Q naught. But we need also to find this relative P1 P naught for each items. Then you multiply by 100. So this is the value. But after you have this value, as we call a P, then you have to multiply by V, as reflected in the as you can see in the formula. So that will be a PV. So down here I'll be keeping just as we'll be summing these values, and here I'll be summing this value. Then we can just take this value, divide by this value, and get you the index. Get your index. Thank you for listening.